In this video, we will explore the elements of circles and the relationships to various lines and line segments and the angles formed by those lines and line segments within circles. To begin with, we have the definition of a circle, simply a shape with all points equal distance from the center. Now, what that means is if we define a point anywhere on this circle, right, we have an infinite number of points that make up the circle, and they are all the same distance from a point in the center of that circle, right? So this is congruent with this. All right, we'll give this a name in a minute. The center is the middle point of a circle. The circle is named by this point. The center of this circle is C, and we would refer to this circle as circle C. A chord is a line segment, right? So if we take a look at segment AB, see it begins on the circle, it ends on the circle, right? Its endpoints lie on the circle, so they start and stop on the circle. Segment AB is a chord. A secant is a line intersecting the circle at 2 points. So line AB is a secant, or we sometimes refer to it as a secant line. A radius, or the radius of a circle actually has many radii. The radius of a circle is the distance from its center to some point on the circle, any point on the circle. And a circle has an infinite number of radii. For this circle, segment CA is a radius. A diameter is a chord which passes through the center of a circle. Notice that this, we could draw many other chords, right, that may or may not pass through the center of the circle. Anytime a chord passes through the center of the circle, that chord is a diameter. So for example, in this circle, segment BA is a diameter. A tangent is a straight line that just touches the circle at one point. It intersects the circle at only one point. So no part of that line is inside the area of the circle. And the point at which that line touches the circle is called the point of tangency. And there are some special properties with that point, particularly with radius or radii that are intercept a point of tangency. All right, we have two types of arcs that we'll define for circles. The first type is a minor arc, and that's this smaller one in blue here. Right? This is a minor arc. It's less than 180 degrees. And we would define this arc as arc AB. Okay, so that's a minor arc. We use 2 letters to define a minor arc. This is referred to as arc AB. Okay, we go straight from A. We take the shortest distance to get to point B. Now, on the other hand, if we take the longer distance to get from A to B, we have a major arc. And notice with the major arc, we define that with 3 letters. What that says is go from point A through point D to end up at point B. It's saying take the longer route. It's greater than 180 degrees. That's a major arc. A semicircle is an arc of a circle having a measure equal to 180 degrees, right? So this arc right here is a semicircle. We said, right, an inscribed angle is an angle formed by 2 chords. Notice that we have a chord here and a chord here, okay, which have a common endpoint on the circle. And that endpoint you will recognize as a vertex. Angle ABD on this circle is an inscribed angle. It has its vertex on the circle. That's the key element. The vertex of an inscribed angle is on the circle. Now, a central angle, on the other hand, is an angle whose vertex is at the center of a circle. And it makes sense, right? We call it a central angle its vertex is at the center of the circle. Angle ACB is a central angle. Now we have a couple of formulas here. I suspect you already know these formulas, but here they are. Write these into your notes. Again, pause this video at any point to write these definitions down. The circumference, represented by the big C here, C for circumference, is equal to 2 pi times the radius, r, 2 pi r. The area of a circle is all the space made up inside the circle, and we have a formula for that. The area is pi r squared. So we take the radius squared, multiply it by pi, and we get area, the big A. This circle's circumference, or area, here are the two formulas. Circumference equals 2 pi r, so we just plug in r in either one of those two formulas. We're plugging in r equals 5. 2 times pi times 5, well, 2 times 5 is 10. Pi, on the other side here for area, rather than taking 5 times 2, we take 5 and square it. 5 squared is 25, so the area, 25 pi. Central angle theorem tells us that the measure of an arc intercepted by a central angle has the same measure. So the measure of angle ACB, so the measure of this angle right here, is equal to the measure of arc AB. We'll stop here and we'll start a new video where we'll do some work with this information, but this video gives you all the definitions for circles, central, and inscribed angles.